Okay, in this video I'm going to talk about unit circle. Unit circle is fundamental topic for calculus, just like table of multiplication, let's say, for algebra multiplication, addition, subtraction, division. It's so important for arithmetical operations for algebra. Unit circle, what is why we call circle unit? Because the radius is 1. This is why we call unit circle. Radius is 1. Okay, so let's see. This is at the initial position of the angle, 0 degrees. This is going, because here we have right angle, this is going to be 90 degrees. This is going to be 180 degrees. Plus another 90 degrees will be 270 degrees. And coming back 360 degrees. Okay, so if radius is 1, so half of it will be somewhere here, providing line. And half of this one will be somewhere here, providing this line. As you can see, it broke the first quadrant. By the way, this is first quadrant, this one is second quadrant, third quadrant, and fourth quadrant. Breaks the the arc of the first quadrant into 3 arcs. Okay, so let me provide a line here. Okay. Since it broke down into 3 arcs, yes, this is 1 arc. Let me write down here 1, 2, 3, 3 arcs, okay, with these points divided. Okay, so let me clean it because I don't want it to look messy. All right, so if it's divided into 3 arcs, and because our circle is symmetric, so here we are going to have 30 degrees. Here we are going to have 60 degrees, right? Okay. So because our circle is symmetric, if I continue here and here, I will get 90 plus 30, I will get 120 degrees here. And 120 plus 30, I will get 150 degrees. Okay. Let me clean this quadrant because we don't need them anymore. Yeah, circle is going to be crowded. So, okay, we got here 150, 120. So now we provide this one. So it's going to be 180 plus 180 plus 30, it's going to be 210 degrees. And 210 degrees plus 30 will be 240 degrees. 240 plus 30 degrees, it's going to be 270. And on this side, if I provide this line, I'm going to get 270 plus 30, it's going to be 300, plus 30, 330, and plus 30, 360. So if I continue here, this line, I will get exactly to 300, and I will get here exactly on 330. Okay, so, and we can take also 45 degrees. 45 degrees is right in the middle between 0 and 90, right? It goes right in the middle. So even if I provide middle, in the middle, split this 90 degrees into angle. Okay, so this point will be 45 degrees. Which means if I provide here line, so 30, I have to add 15 to get 45, so 120 plus 15, I'll get 135. Or you can take average between 120 and 150. Add them up, divide, you will get right middle. So, or just 120 plus, 30, plus 15 degrees. Next, moving this down. So 210 plus 15, it's going to be 225, which is also average of 210 and 240 degrees. Okay, and 225, I provide here line on this side. I will get 315 degrees. So there we go. You have circled the most common angles you can use. Now let's represent in the format of radian. So one more time, what is radian? A radian is 1 radian represent an angle that is created by it's not created by radius r and arc that is equal r. I'm not sure if it's equal. No, it's not equal, but use your imagination. It's supposed to be equal because both of them are r, right? And that will be 1 radian. So in my the previous video about angles, I showed that 1 radian, it's about 57 degrees. So as you can see, radian is greater than degrees. Okay, let's move to represent the same angles in the format of radians. So here we have, starting with 0 pi, if you want to. I can put 0 pi or 0. Okay. Then 30. How I'm going to calculate this 30? Let me see. To convert any degrees to radian, we need to take that degree. In this case, it's 30. And then times pi over 180. Okay. Pi over 180. This is 1. This is 6. And the answer is going to be pi over 6. So 30 degrees is going to be pi over 6. Okay. Next. Uh, 45 degrees. So next is 45. So I'm writing down 45. Pi over 180. This is 1. This is 4. So pi over 4. Okay. Next, 90 degrees. Ninety times pi over 180. 1 and 2. Pi over 2. Oops. I'm sorry. pi over 4 comes here. All right, I'll put 60 in a minute. Pi over 2. And 60. So 60 divided by 180 is going to be pi over 3. Okay, and 120 I'll show you, and the rest I can fill it up because you already know how to calculate, right? Okay, so 120 times pi over 180. So 0 is gone with 0. 12 and 18 can reduce by 6. This is 2. This is 3, 2. So it will be 2 pi over 3. Okay. And accordingly, 135 will be 3 pi over 4. And then 150, 5 pi over 6. 180, we know that's a pi. Yes. Take a little bit. And 210 will be 7 pi over 6. $225 will be 5 pi over 6. I mean 5 pi over 4, I'm sorry. 240 will be 4 pi over 3. 270 will be 3 pi over 2. 300 will be 5 pi over 3. So all of them you calculate precisely the way we did here, drafting. So you take the degree. Okay, let's do 315. 315 times pi over 180. Okay, we can divide by how much? I think 45. 180 by 45 is gonna be 4, and 315 by 45 7 times. So we get here 7 pi over 4. 330, let me clean this. 330 degrees will be 11 pi over 6. Oh, let me see. Yeah, well, it's not bold enough. All right. And here let me add also this one from 45. It will go down straight to 315. Okay, this is the unit circle and angles, most common angles located on unit circle. So why do we need that? We are going to use in trigonometric functions. That will be my next video, trigonometric functions that also are known as circular functions, as an angle function, or goniometric function. Okay, those are functions that are relating and working with angles of the right angle triangle to ratio the two sides side length. Okay, and they are widely known as trigonometric functions, and that will be my next topic, and we will see how we will use these how we will use this degrees and radians format of angles and on the unit circle to identify the value of trigonometric functions. Okie dokie.